Alright, this is our very last video for the year. We were doing this first section in 13 only because I wanted to introduce some of the trig stuff to you, because for those of you moving on to pre-calc next year, which should be a decent number of you, I want you to make sure that you are exposed to this, and that if you have looked at it before, that you are refamiliarized with it before moving into next year, because there is a big chunk of pre-calculus that is trigonometry. So, let's go ahead and take a look at what is trigonometry. And trigonometry is simply the study of the relationships among the angles and sides of a right triangle. So we're putting together relationships and ratios. They're going to put together sides of a triangle along with its angles. So very specifically, and there's a lot of information here, the things that you have to copy down are those ratios down at the bottom. So I'm going to go through all of this, so kind of as you're writing, make sure you're paying attention to what I'm saying as well. So it says, if theta is the measure of an acute angle of a right triangle, opposite, or the OPP, is the measure of the leg opposite theta. Now I'll draw a triangle here in a second, and I will show you all of this. Adjacent, or the ADJ, is the measure of the leg adjacent to theta, and HYP, the hypotenuse, is the measure of the hypotenuse. Then the following are true. So if those are the cases, then this is true. Sine of theta, so the SIN is sine, is equal to the opposite over the hypotenuse. Cosine of theta, the COS, is equal to the adjacent over the hypotenuse. And the tangent, or the TAN of theta, is equal to the opposite over the adjacent. Now we have three other ones. So those ones you may have seen before. The three at the bottom you may not have seen before, and these are the reciprocal ones. So cosecant, the CSC, is the reciprocal of sine. So it's simply the hypotenuse over opposite. And then secant, which is SEC, is the hypotenuse over adjacent, and the cotangent is reciprocal of tangent, which is the adjacent over the opposite. So make sure to have those things copied down. I'm going to draw a triangle, and I'm going to show you what I mean when I refer to opposites and adjacents and the hypotenuse. Alright, so in this little triangle over here, you'll see I have it marked with opposite, hypotenuse, and adjacent. So if you notice, I do have the theta marked in there. So that angle right there is our theta marking. Okay, so that's the angle we're referencing. So that angle is now the control of all of this triangle. Because if this is the angle we're referencing, the side opposite this, if you go across the triangle, this is the side opposite. And then the side adjacent to it is one of the sides that's forming it. However, you always know this is the hypotenuse because it's always the longest side across from the right angle. So that you should know from right triangle stuff, from geometry. So since this is a hypotenuse, that has to make this leg the adjacent. So the opposite and adjacent are always the legs. It's just going to switch. Now, if I were to change this up and make this my theta, that means this would no longer be opposite and this would no longer be adjacent, but this would be the opposite and this would be the adjacent. This stays the hypotenuse. So that's going to change based on where your angle theta falls. And then that's how you find all of those ratios. Alright, so let's go back over here, and we are going to do an example of some of these things. On how to find these ratios. So they give us a triangle, and it says the sides are 3, 5, and 4, and they tell us that theta is in this upper corner here. This upper angle. So they want the values of all 6. So what I do is I'm going to start with sine of theta, cosine of theta, and tangent of theta. Once I find those three, all I have to do is take the reciprocal to find cosecant, secant, and cotangent. Alright, so sine is always the opposite over the hypotenuse. Well, the opposite of theta is 4, and this is my right angle, which means my hypotenuse is 5. So this is 4 over 5, and that's all it is. It's a ratio. Cosine. Well, here's my theta. Cosine is always the adjacent over the hypotenuse. So what side is adjacent to theta? It's the 3. Can't be the hypotenuse, so it has to be 3 over 5. And then tangent is always the opposite over adjacent. So that would be the opposite, which is 4, over the adjacent, which is 3. So it's 4 over 3. So those are my 3 base trig functions. Now these ones are all just reciprocals. So cosecant would then be 5 over 4. Secant is 5 over 3. And cotangent is 3 over 4. So once you have the sine, cosine, tangent, it's easy to find the cosecant, secant, and cotangent. And I'm hoping you've done some of this with sine, cosine, and tangent last year in geometry. Alright. Now, I want you to copy down this table. What this is just some, based on, now this is going to make, you're going to find out how to find all of these things next year in pre-calc. But what this is just some very special angles. The 30, the 45, and the 60 are special angles in trigonometry, and they're ones that you reference a lot. So I just have a table here so that you have these. I'm not going to make you memorize these. I'm not looking for you to know these off by heart, but I do want you to copy them down because you're going to use these more often than not, especially when you reference 30, 60, 90 triangles, 45, 45, 90 triangles, those kind of things. So go ahead and take a minute, make sure to copy those all down, and then we will move on to the next part of the video. Alright, so they want us to write an equation involving sine, cosine, or tangent that can be used to find the value of x. Then solve the equation and round to the nearest tenth. So what we need to do is take a look at the angle that's given. So we have 30 degrees down here. And over here clearly is my right angle. So if this is 30 degrees, what you want to do is look at the sides that they gave you. So I have the 8 and an x. And you want to determine what are those in relationship to the angle. Well, here's my right angle, so 8 is my hypotenuse. So I have the hypotenuse, and x is adjacent to 30. So once I recognize I have the hypotenuse and the adjacent, I say which of my 3, sine, cosine, or tangent, relates the adjacent to the hypotenuse. Well, if you look through your ratios, we recognize that cosine of theta is equal to the adjacent over the hypotenuse. So what I'm going to say then is cosine, and I know my angle, 30 degrees, is equal to, we don't know what the adjacent is, that's x, over 8, which is our hypotenuse. So the first part, find an equation, this is your equation. So that's the equation that we write to find out what x is. Then they ask us to actually solve for x. So what I have to do is multiply both sides by 8 to get x by itself. So I multiply that, we end up with 8 times cosine of 30 is equal to x. And all we do is plug this into our calculators. You're going to plug in 8 times cosine of 30, and that's going to give you a value. So once we do that, we plug that in, we get a value for x, and that value for x ends up being 4 times the square root of 3. Now you could write it this way, or you could leave it as a decimal, or whichever way you prefer. The book will often give you the radical answer for that. So when you're checking your work, you want to make sure you're used to that or ready for that. But as long as you multiply 4 times the square root of 3 and get the same decimal, then you're okay. But the important part here is recognizing what two sides you're given in relationship to the angle that they started you with. Alright, my next two examples are going to be a little more involved. On your papers, you'll notice that you have the triangle, and they ask us to solve the triangle. What it means when it says solve the triangle, and they give us, so this is x, our right angle is angle z, and down here is y. So it says solve x, y, z. What that means is they want us to find the missing angle, so we're still missing y, and they want us to find x and z. So all the things that you're missing, you have to find and solve this so that you know all the angles and all the sides. Now, the angle is the easiest part to start with because we know a triangle has 180 degrees, and I know 35 and I know 90. So the measure of angle y is equal to 180 minus the sum of 90 plus 35. So that gives me 180 minus 125, which is going to give me a measure of 55 degrees. So that's one piece of the puzzle. We're looking for 3 pieces. That's the first piece. Now the next piece, so I know now this is 55 degrees. I now want to find x and z. What we have to do is very similar to what I just did in the last example, except we're going to pick one of our 2 angles. So let's say I pick 35 first. Okay, it doesn't matter which one you pick. Let's say I pick 35 first. I know side 10, and I want to find side z. So what would relate with 35? According to 35, this is my adjacent, and this is my hypotenuse. So what relationship relates those two? It would be cosine. So we're going to say cosine of 35 degrees is equal to the adjacent, which is 10, over the hypotenuse, which is z. Now this one we have to do a little bit more work because I have to multiply by z, so I end up with z times cosine of 35 is equal to 10. But now I have to then divide by 10 cosine of 35. So we end up with z is equal to 10 divided by the cosine of 35. So there's just more algebra work included there. And if we look at that, what we end up getting is 12.2 is equal to z. So that's the second piece of our puzzle. Now the third piece of our puzzle is going to come when we try to find x now. So what I'm going to do is I'm going to get rid of these because I'm going to choose a different angle. Or I could choose the same angle if we wanted to. We could still go with 35, or you could go with 55. It doesn't matter whichever way you want to do it. Let's stick with 35 just to stay consistent. So according to 35, this is still the adjacent. X then would be the opposite. So I'm not even going to use the hypotenuse. We're using the adjacent and the opposite. Well, what relates that? It would be the tangent of 35. So the tangent of 35 is the opposite over the adjacent, so it's x over 10. Now this one's easier because I can just multiply by 10. We get 10 times the tangent of 35 is equal to x. So when we put all of that into our calculator, x is approximately 7.0. And that's this third piece of our puzzle. So then we know that x is 7.0, z is 12.2, and y is 55 degrees. So there is quite a bit of work to be done there. So these are longer problems when they ask you to solve the triangle. But again, it sticks with that same thing that we just did in the last example. You want to pick an angle and figure out the two sides that I'm looking for, the sides that I have and the side that I want. How do those relate, and which of my three functions relates those two sides together properly? So we are going to look at another example of how to solve a triangle. Okay? Because I know these are long and involved, and I want to make sure that you're comfortable with these. So give me a minute to erase. Okay, so again, solve for ABC. Now this time, they didn't give us any angles. They only gave us the three sides. Well, right off the bat, I know one of them has to be, so we have A, we have B, and we have C. So I know one of them has to be 90 degrees, that's down here. So I know the measure of angle B is equal to 90 degrees. So that's one piece of the missing puzzle. Easy to find. One of them has to be 90, so we're done. Now we need to find angle A and angle C. And you can't just say 45 and 45 and divide the other two up, and you can't just say 30 and 60 because we know it's going to be that way. What we have to do is, again, pick one of our angles. So let's say I pick angle A, and I'm going to make it theta for right now. I pick two of the other sides. It doesn't matter which two. You pick any of the other two sides. So let's say I were to pick 12 and 13. What relates, according to A, this is my opposite and my hypotenuse. So what relates the opposite and the hypotenuse? That would be sine. So what I'm going to say is the sine of A is equal to the opposite, which is 12, over 13, which is the hypotenuse. Now here's where it gets a little tricky, because what we actually have to do to find this is say A is equal to the inverse sine of 12 over 13. If you look on your calculators, above the sine key, so if you were to hit, so I'll put the key markings here, if you were to hit second, and then the sine key, which should give you sine inverse, and then you hit 12 divided by 13. That's going to give you your answer for A. So then the measure of angle A for that particular problem will end up being approximately 23 degrees. Then we can go through and do the same thing for B, or for C, excuse me, for C. So now that those are done, I'm going to erase that. So now let's say, okay, now my theta is over here. And again, you can pick any of the three sides. It doesn't matter because our theta has changed. So let's say this time we choose 5 and 12. This is my opposite. This is my adjacent. So that means I'm looking this time at the tangent of C is equal to the opposite, 5, over the adjacent, which is 12. And again, you're using the inverse tangent of 5 over 12, and that will give you approximately 67 degrees. Now the other thing you could do is, once you know this, you could say, okay, 90 and 23 gives me 113, take that away from 180, and you should get 67 degrees. But you could do it, so we could have started here and did this one and then found this one. You could start here and then go here. It doesn't matter how you set that up for this particular problem. There's a number of ways that you could do that. Alright, and that is the homework, or that's the lesson. So your homework is going to be on page 765, 13 through 27 odd. So I do want you, I know I'm not going to be around to answer questions, but I do need you to do this and to complete it because your test is coming up when I get back. But you need to make sure that you are up to speed on this, helping one another out with those things. So, believe it or not, you just finished your last video for Algebra 2. So you've officially completed the course, and now it's just a matter of finishing off this last test and taking the final next week, and we are almost there.